Hello. Okay. Fair warning, I'm still dealing with the cough, so if I start coughing, I'm not dying. Anyway, Bessie, bootstrapping on bare metal button. There we go. First of all, who am I? I'm Gideon, or known as Ghetto Online. It's all the same to me. I'm a first year CSEC major. I'm a Linux sysadmin. I have multiple former and current jobs in education for some reason. Well, because I can. I formed a dangerous engineering mindset at a very young age. And as employee disclosure, I'm talking about something I've discussed. I'm working, words. I'm talking about something I worked on with my employer. However, everything I'm saying is my own opinion, and nothing I say represents Starfield or any other employer I have. Anyway, who's Bessie? It's not a who. Like, come on, this is not about people. It's a talking about platform goals. So it's an internal code name for our web-based VM platform at the company I work at, Starfield, which is an educational nonprofit in the DC area. It's the whole goal of this is that we could run a VM somewhere else and have it accessible over a web browser, so no matter where we go, it is functional. We can run whatever we need to for like cybersecurity and programming lessons. Button? Oh, that's the wrong button. There you go. The same after Henry Bessemer, who invented the Bessemer steel smelting process. It's some industrial stuff. You pump air through it, it makes it cleaner. It doesn't really matter. It runs on the Equinix Metal platform. It's a platform where you can rent servers by the hour, which is really nice. Bare metal servers for I think a pretty good price, even without like a long-term contract or anything. And that's where the name came from: steel, metal. As the VMs must be accessible from a web interface. It's one of the big goals. We have to be able to access them anywhere. So anything with a web browser is a potential client, including Chromebooks, which I'll get to later. The web interface should be performant. It shouldn't suck to use, because if kids are using this stuff and it's like slow and like nothing that works, they're going to be really tired of this really quickly, and that's kind of my job, makes it not tired of it quickly. We don't want to require software on the VM, so no VNC, no RDP, nothing of that. All the guests should be normal. If it's booting to Grub or to a console, it needs to work, and so that is a kind of a weird requirement, but it ends up making it a lot more interesting and have to work a lot better. It also needs to deploy with minimal user input. I won't always be there to go and deploy it. I'm not in DC right now, and so it needs to be able to be run on its own. It needs to be able to be destroyed overnight, because with bare metal servers, anytime you reserve the server, you're being charged, and so we don't want to run up big bills, and so overnight when no one's using it, it needs to be shut down and then brought back the next day. And you also want to avoid IT departments. School IT departments, I'm not going to name any names, but they're kind of a nightmare, and so we don't want to deal with them. And so we don't want to deal with like, hey, install VMware on your machines and going back forth 3 hours, or not 3 hours, 3 months, and then they're like, oh, well, we paid you for a contract. No, we're not doing that. We're just avoiding that entirely. One week note on Equinix Metal, because I know someone who works there. They supported Equinix Metal is very supportive of us with funding. We've had huge discounts, which has made it possible for us to start this in the first place, and for me to test all this stuff, which is not a cheap thing to do. So thanks Equinix for giving us a whole bunch of 24-core Epic servers to play with for a while, and then also teach children on. So a couple options I ruled out fairly quickly. Public cloud. There's no sane way to intercept the VM graphical output on public cloud. It's kind of annoying, but this is what it is. Like you have to have VNC or something running on the actual VM, which means that something can go wrong easily. Also, Terraform. As far as software goes, Terraform's okay, but it's not really automatable for what we need. You can't scale up and down easily. You can't say, make me 4 new servers and then delete those 4 servers without destroying the whole setup or editing your configs. I wanted to be able to say, I need a server right now, I need 2 servers later, and so on and so forth. And so Terraform, I tried using it, and then I decided it wasn't working. And Proxmox, more on that later. I don't like Proxmox very much. The first incarnation was kind of a disaster. It was set up for a middle school summer camp in the summer of 2022. The camp went pretty well, and I made it work, but there was not enough time allocated to this. The project was I thought, oh, I can start like the week before. Like I had like the basic stuff set up. Like the week beforehand, I'll start actually working on it. It'll be fine. It was not fine because I was using Proxmox at the time, and Proxmox doesn't work the way I needed it to. It couldn't be deployed automatically because Proxmox clustering sucks. You can't do clustering without the root password, and because it's all automatic, that means a root password in plain text on a server I can't control. I'm not doing that, and also you can't get the like graphical output. You can see a VNC console inside Proxmox, but getting to output something else, you can do it, but it's being kind of a pain, and I kind of got tired of it all. I ran out of time. There's a thing with Guacamole where basically it's by Apache, where you can take a VNC or RDP output and shove it into a website. It works really well when you have an actual like thing that works, but Proxmox made that very difficult. And it also was not very performant. There's like all the output was pretty slow. And so we built all this. It was not ideal. My boss walked in like the third day when we were running it. And he was like, "Wow, it all seems working pretty well," because I kind of bodged it together, as we'll see here. He did not see the fact that all the students got logins to the Proxmox page, which I printed out on my home inkjet the morning of, with saying, "Log into this, go to the machine that matches your number, and do it there." That was not ideal. It actually worked for the week, but I could not deploy that reasonably on like a larger scale. That was never going to happen. It worked surprisingly well, given the situation, but and like I think my boss was impressed I could make that kind of disaster work, but it was not good. We could not deploy this like for 50 students as it did later on. So current solution, the slave nodes are configured to be a salt stack, which is like Ansible, but with brains. It knows what it's doing on Ansible, which is basically just like sending commands over SSH. Ansible I've grown to like a little more, but I still like Ansible very much. Salt stack's way nicer in my opinion. Also run libvirt on the slaves. You have to do this with a Golang server. Golang is the hammer to which I put in nails and screws alike. But for this situation, it's actually kind of a good answer because it's like back-end server stuff, which is what I like doing. So that's nice. It basically connects all of them. You can, as if you're on the same machine, you can say make a new VM and do all that other stuff. And some commands run over SSH for things that aren't directly connected to libvirt. There's also a web interface that connects with Spice. Spice is like VNC, but made for VMs, which means it works really well. It's really performant. Way more performant than VNC in most situations. You can do nice things like inputs, like keystrokes are handled correctly instead of just like holding on the key too long is a complete disaster. And you get a much higher quality video, which is nice. I mean, you need some tweaking, but you know, I had over a year to work on this, and so I could make high quality video a thing. And it also has optional integration with guest OS, so when you set that up, you can have everything work together nicely. It's all nice. It works actually really well. The hard part, though, is automated bootstrapping. You have a server, and you got to make that into a thing that works with no user interaction. That is like shockingly difficult. You know, the things that really matter is like, you know, and so your bootstrapping, for the record, is taking like a blank server or VMware equivalent and making it useful, like configuring it to be used. Doing it by hand is not too hard, but it's very difficult for the first server, especially because you have nothing to start with. For all the other, after the master is set up, like you basically just say connect the salt stack and go, and it just kind of works. But for the first one, you have to do everything from your local laptop, basically, which is, or you can do a VM somewhere else, I guess, but it's all a big pain, and it's especially because it has to be written in a way where someone other than me can run it. That was like months of work, not continuous, obviously, but like that was months of work. It's mostly written in Bash because you know that's all you really have at first in the Debian box is Bash. It's difficult to debug without running, unlike even like Python, which is interpreted still. Like you can kind of debug that reasonably. You can't. Bash is the name which you go and debug. You can, but people, it's not necessarily even easier than just running it. But every time you make a change, you can't do it iteratively. You have to reset. You have to basically rebuild the whole machine, which takes a long time, and so you can't do like a small iterative change on the whole system. You can like log in and run another command, but then you're just kind of testing one thing. You can't go multiple steps forward. And so key points to hit is that when you're setting something up, you have to find some way to copy over information from your laptop or wherever you're deploying from to the server you want to bootstrap. I like to use SCP to copy over a bash profile. From that, you can just import, you can source the bash profile, and then you can just have all your variables. That works fairly well. It's not like the greatest thing in the world, but it works at least. You install all the packages you might want. And I don't just mean like, oh, I want Git. It's like every single library and every single other thing. Any little thing you do has to be written in code, or else it won't happen, which is kind of a nightmare. You also have to configure the network interfaces. Especially you'll lose connection when you do that because you'll probably be changing the IP address or routes or something, and so that's always not very fun. You have to start filling out the configuration files. For things you might want to start, and then you have to reboot. You always have to reboot when you're bootstrapping because, for networking, it makes things easier because it will come back up the way you want it to, and then if reboots again in the future, it'll keep working. Then you have to use other configure certificates because your web server is probably not running. You have to configure your storage arrays. That's a big thing. You have to create file systems. Like we had, the servers we had, they booted off of one SSD, then I had two other SSDs that we put in a RAID 0 for what is like a scratch disk basically. That was a big, you had to configure that somehow. And different servers are technically the same version. They were different versions of the same version, or same tier server, and so you have to change which way you hard code the drive. It was a big pain. But you can make containers for services. You could not use containers, but probably good to use containers for these things, especially for the salt master, which you don't want on the you want that's isolated so it's somewhat separate. If the memory sets up to auto start because you might reboot eventually. And again, everything is auto restart. You pull apart his code from whatever, like GitHub or whatever else. It also usually means copying over a GitHub sh deploy key, which is a bit fun, or generating one, then telling the user, hey, add this to your GitHub deploy keys list. Start running salt stack. Salt stack is what I use to do anything I didn't absolutely need to do in Bash. What makes this particularly hard? Like, that might sound simple, but also, anytime you screw any little typo up, it's 5-10 minutes. Like, there is no fast deploying of a server, pretty much. It's at least 5-10 minutes for every step you do. So you might have made one little typo. Now you're sitting there 10 minutes, waiting for it to go through, and eventually it might work. You also consider every little dependency. You have the fact that you have to pass data securely between servers, which never really had a secure handshake. You don't have a good outer band way to verify anything, so making it vaguely secure is actually kind of hard. We sort of made it work, but it is not fully zero trust, I'll admit. It's pretty good, but I wasn't going to implement a certificate authority for this. Which you could do, but that's a lot more work. And also having to manage destroying servers. That was, you have to manage hey, I had a server and now it's gone. All the VMs on it are now gone. You have to make sure it's removed from the database. And you might want to keep logs of that somewhere. And so that's a whole big thing. Or sometimes servers go away for other reasons. You have to make sure you have checks for everything you do that say, hey, is the VM still here? Is the disk still here? Everything else. You also have areas to handle. And so, other parts of the system. The captions worked. Good. Beyond that, beyond just the VM part, you got to run some other stuff. I have a written in Golang authoritative DNS server, which responds for the domain for the cluster. That way, I have a way to access all the nodes in the cluster from some sane way, and it's read straight off a database. But that was a decent bit of work. So the Mike G DNS package in Golang is really good. So if you're doing DNS in Golang, use it. You have to handle distribution of the base VM images. You have to be able to, have pretty big files that have to go somewhere. You have to make sure that the VMs have a capacity to run more VMs. We had it set up so every machine was 6 VMs, but there's nothing hard limiting that, so you have to make sure you're not over provisioning, which would cause other issues down the road. Especially because all the VM drives are not, the whole disk isn't provisioned at once because that's a lot of storage you'll need to use. So keep track of what VMs go to what spice connections. And there's a lot of fun with that. So most of the backend run of IPv6 because that's what I like, and also it makes them kind of easy. And routing is a bit easier that way. for this setup. However, it means you have to do proxying to a WebSocket so it works on a web browser, because web browsers can't do straight TCP connections normally. And so that was a whole bunch of typing things around in a way that's not terrible. You also have to enroll nodes into SaltStack in a semi-secure way. SaltStack, you have to do a key exchange. Unlike Ansible's and work over SSH, it works over its own thing, and so you have to somehow figure out a way to enroll the new nodes and do a key exchange that doesn't completely suck. And you have to check that the libvirt connection is still alive. Those sometimes die. Sometimes the server dies, and there's I think a DigitalOcean package in Golang for libvirt that actually is decent, but it doesn't always check the connections being alive, and so sometimes you'll just get a panic because it didn't check for that. So there's a couple optimizations that we did. We installed the QEMU guest tools on the guests whenever possible, and not always possible. When you can, it makes things a lot better. So keyboards work a lot nicer. Also had buttons to the front end to handle stopping and starting VMs and setting Control-Delete. This is an optimization because I hate front-end development a lot, and so for the first and second implementations, there's no way to start a VM you stopped. So if you shut down a VM, the VM was gone until I got back to it. And I usually wasn't doing the lessons at that point, so that was hey, here's extra 4 VMs. Hopefully no more than 4 students shut down their VMs. It worked out, but eventually I had buttons to do it. It actually wasn't that hard, luckily. You have to use a backing file for the VM disks to minimize storage usage instead of copying the entire disk every time for the base image. You just copy and write essentially. You only copy bits that change, which is a lot easier on the storage. So set up UEFI support for Windows VMs because Windows really wants EFI, and so you got to somehow give it a way to do that. And you have to spend hours and hours trying different configurations of graphics drivers to find the exact one that works pretty well and doesn't completely suck for that one situation. It's also surprisingly browser dependent, not just Chrome, but Chrome on what machine. Chrome on my laptop it would suck, but on the school issued machines it were fine. So I was well, it works there, so I just kind of gave up on optimizing more at one point, and just it works on the user machine, so I'll deal with it. Also helps that this was near DC, and all the servers were in Ashburn, Virginia, which is very close to DC, and so latency I think was already very small. The latency didn't seem to be too sensitive, which the whole system wasn't very latency sensitive, which we found really interesting. Anyway, conclusions. Infrastructure as a service, it sucks. I'm gonna keep doing it anyway because for some reason every time I look at getting a job or something, it's always infrastructure as a service. It seems like it's a thing. I'm getting better at it, but also I continue to hate it more and more. Anything with Terraform or anything is just kind of, or any kind of things they work, but there's so many small things. It takes so long to debug. And there's no good way to make a testing environment either. Button. Hello. Come on. There we go. Whatever. Thanks. Things always take longer than you expect. Especially these kind of things. So you can always allocate more time, but it won't work. It'll always take longer than you allocate. If you allocate 5 years, it'll take you 10. It's dumb. And even by the 10 years, you might still not be completely done. Also, most of the trendy software packages, they suck. Things like, Terraform and all that, and there's Pulumi, which is based on Terraform. They all are pretty awful, actually. The only real useful thing is for using them as an API reference to just do it manually. I just in Golang, and actually Equinix's Java Equinix, they have very good documentation for their Golang packages and APIs, which made it so much easier because they didn't have to reverse engineer the Golang directly. But writing the code itself was way quicker than doing all the time I spent on Terraform stuff was way less than it was as a whole. The rest of the work was just, once I did Terraform, it was, once I read Terraform, just did it manually, it was actually pretty quick. Comparatively speaking, which took a couple weeks. And also thanks to my boss, Charles, for supporting this project. It was not a cheap project, and it was not a necessary project necessarily. Well, until we got saved last summer by in Baltimore when we showed up with half as many desktops that were running Windows 7 in the year 2023, and then they were like, "Oh, we also have Chromebooks." I'm like, "Hey, boss, you know this thing I'm working on, right? It works on Chromebooks," and that saved us there. So thanks, Baltimore. Actually, they were lovely to work with. I'm giving them crap, but computers are expensive, and we clearly made it work. And all this wouldn't have been possible if my boss wasn't flexible enough to deal with over a year of this kind of work, and this wouldn't happen otherwise. I wouldn't do this for myself. Anyway, any questions for anyone who's stuck with this stuff? Chase?
How many actual hours did it take to work on this project from start to the end?
Oh, I don't like looking at those numbers because those are big numbers. I would be not surprised if I logged between 50 and 80 working hours, at least. Yeah, so it was, and I was not working full time, so this was like this over the course of months because I was still a high school student at this point, doing it normally in class. But, it works. Any other questions? Good. You should not carry infrastructure. It's garbage. Don't do it.